Welcome back, ladies and gentlemen, to another video with Mr. Kenton. And I wanted to put together a video for you guys that walks you through how to do a titration problem where you're doing some calculations and understanding what are the pieces of information that you need, how would you go about doing that? Because certainly, like we talked about in the previous video, there are some conceptual pieces that you need to keep in mind, like analyte, titrant, endpoint, equivalence point, and thinking of the particle representation of what's going on throughout the course of a titration. But ultimately, like in order to get to the equivalence point, we need to understand something about what's going on from the reaction component, right? So from the stoichiometry. And so that's where doing a problem like this, I think, is going to be very helpful. So hopefully, you're going to be able to follow along here pretty easily. And of course, the great thing about me working out videos and problems like this, you can always pause it, rewatch it, go back, check over yourself, make sure you understood what I was saying. So hope you guys find this insightful. Let's go ahead and dive into the question that I'm going to have us take a look at. Okay, now it says, the problem states there's a commercial method that's used to peel potatoes, and what they do is they soak them in a solution of sodium hydroxide for a short time. They remove the potatoes from the sodium hydroxide and spray off the peel. This sounds like really appetizing, doesn't it? The concentration of sodium hydroxide is normally in the range of 3 to 6 molar. The sodium hydroxide is analyzed periodically. In one such analysis, states that 45.7 milliliters of 0.500 molar sulfuric acid is required to neutralize a 20 milliliter sample of that sodium hydroxide solution. What is the concentration of the sodium hydroxide solution? Okay, so there's a lot to kind of digest there. But ultimately, before we go into trying to solve this particular problem, I think it's important for us to recognize or identify what's reacting here, right? I think kind of the first thing that we should note is that we're told that we have a base, we have some sodium hydroxide, so that's NaOH. Now they're talking to us about how it's resting in a solution, and so that's going to be aqueous, right? And then they also tell us that the way they determine or analyze the concentration of the sodium hydroxide is that they reacted it, or they neutralized it, with some sulfuric acid. So we've got some H2SO4, right? So we've got some sodium hydroxide that's reacting with sulfuric acid. Now, obviously they don't tell us the products, but we should know how to be able to predict that, right? So this is an acid-base neutralization, and so in a sense it's kind of like a double replacement reaction, and we're going to get the formation of sodium sulfate, Na2SO4, aqueous, plus water, because it's an acid-base neutralization reaction. Now, the only thing we need to do before we try to even tackle any of the other pieces of information that have been given here is we need a balanced equation, right? We're doing stoichiometry. We have to have that balanced equation. And the thing that I notice is that I've got 2 sodiums on the right. I only have 1 on the left currently, so I'm just going to put a 2 in front of my sodium hydroxide. That gives me 2 sodiums. We got 1 sulfate, and then it looks like we've got 4 hydrogens because we got the 2 from the sodium hydroxide and 2 from the sulfuric acid. So I think if I put a coefficient of 2 in front of my liquid water, I think at this point we have got a balanced chemical equation, right? So that kind of gets us started. Now, if you think about it, from this particular context, from the question, they told us that we had a volume of sulfuric acid
that was 45.7 milliliters.
And they also told us the concentration
of H2SO4. And by the way, remember that you can represent concentration by simply placing the substance in brackets, and that just stands for concentration. So the concentration of the sulfuric acid was 0.500 molar. Okay,
So that's the information they gave us about the sulfuric acid.
and then they told us that we had a volume of sodium hydroxide that was 20.0 milliliters.
And they want to know,
what is the concentration of sodium hydroxide? That is the piece of information that we are trying to find. Now, kind of put this in context when we're thinking about like our analyte versus our titrant. In this particular case, our analyte is the sodium hydroxide. We've got some volume of it, but we don't know what its concentration is, so that's our analyte. And our titrant, in this case, is going to be our sulfuric acid, right? Because we know the amount, we also know the concentration of that sulfuric acid. Okay, and so as we begin to approach this problem, because we want to end up with the concentration of sodium hydroxide, we're going to end up starting with, when we approach our problem, starting with everything that has to do with our sulfuric acid, right? And I know I've talked about this with you guys in class, and so I'm just going to kind of create a roadmap for us before we even do any of the other calculations. We know that ultimately that we're going to be starting in a sense of molarity of H2SO4, right? That's where we're starting. Our endpoint is we want to get to the molarity of sodium hydroxide. Well, in order for us to do that, we're going to start with the molarity of the sulfuric acid, and then we're going to go to moles of sulfuric acid. Once we get to moles of sulfuric acid, I want to be able to go to moles of sodium hydroxide. And then once I get to moles of sodium hydroxide, I should be able to get to the molarity of sodium hydroxide, right? So that's kind of my roadmap. That's going to be the process in which we're going to be using to go from my sulfuric acid information to my molarity of my sodium hydroxide. Now, when we look at this, if we're starting with molarity, the good news is if I want to get to moles, I simply just need to multiply by the volume that I have of that particular solution. So I can say, all right, I've got 0.0457 liters of H2SO4. And I know that I've got 0.500 moles of H2SO4 in every 1 liter of my H2SO4 solution. And again, all I did there is I took the volume of the sulfuric acid and I'm multiplying it by the molarity that they gave me of the sulfuric acid. So that gets me from liters of sulfuric acid to moles of sulfuric acid. So that's checked off. My next step, going to moles of sodium hydroxide, is going to be taking a look at the balanced equation and looking at the mole ratio. Now, in this particular case, for every 1 mole of sulfuric acid that I have, that's going to require 2 moles of sodium hydroxide to neutralize it. Right? And we see that there's a coefficient of 1 in front of the sulfuric acid, coefficient of 2 in front of the sodium hydroxide. Now, in doing that, that takes me to my moles of sodium hydroxide. And then my last step of getting into the molarity of sodium hydroxide, I'm currently, if you think about it from a unit perspective, my liters of sulfuric acid canceled, my units of moles of sulfuric acid canceled. So now I've got moles of sodium hydroxide. If I want molarity, remember molarity is simply moles divided by liters, or moles divided by volume. All I'm going to have to do is I'm going to take this volume of sodium hydroxide they gave me to begin with, and I'm going to divide it here. So I can just simply say, all right, in my dimensional analysis, if I just place 0.0200 liters of NaOH on the bottom, that's going to leave me with moles of sodium hydroxide over liters of sodium hydroxide, which is what I'm trying to find. And so then I just plug that into my calculator. And so I've got 0.0457 times 0.5 times 2 divided by 0.02, and I get that the concentration of NaOH that I'm using, or that's being used to peel off those potatoes, has a concentration of 2.29 molar. And if we think about what this is communicating, once 45.7 milliliters of this concentration of sulfuric acid reacts with the 2.29 molar sodium hydroxide, that 20 milliliters, that's when the reaction reaches its equivalence point. At that point, that means all of the sulfuric acid and all of the sodium hydroxide have been consumed in that particular process. Okay, I hope that makes sense. Good thing about videos like this, if I went too fast for you, you can always rewind it, you can go back, you can slow it down, whatever you need to do. But please use this video as kind of a reference to help you kind of set up and approach how you would go about solving a titration problem. Thank you guys for joining me, and I look forward to seeing you guys again soon. Take care.